Hi, my name is Bruce Bradley, and for the last few years, I have focused on making seaweed extract from recycled geoduck nets. And I sell the extract as a biostimulant fertilizer at local farmers markets around Vancouver Island. I also created two cosmetic products, a seaweed zinc oxide lotion and a seaweed face and hair tonic to sell alongside. I started making biochar a few years ago, and I thought there could be many more applications for biochar in aquaculture. And I began to dig deeper into the subject. I started by researching and recruited some help to write a paper on biochar and its potential applications in aquaculture. And I learned that biochar can help aquatic plants and shellfish adapt to ocean acidification and ocean warming, the two most difficult challenges facing coastal ecosystems today. Biochar has many unique qualities that provide an advantageous habitat for young seaweed and shellfish in their most vulnerable stages of life. Indeed, what a kelp forest does for the ocean on a macro scale, pH buffering, nutrient storage, habitat services, biochar does on a micro scale, providing ideal conditions for the microbes that support the health of tiny aquatic plants and shellfish. Kelp researchers have talked about the need to create an artificial substrate with a textured surface to improve gametophyte retention, and biochar is indeed nature's most perfectly engineered material for this cause. It has an incredibly large surface area, lightweight, and variable size. This dramatically increases the individual piece count and surface area available for the cultivation in a hatchery or in open grow-out conditions. For example, one 5-gallon bucket can hold 5,000 individual pieces of kelp on biochar, greatly increasing the scalability and survivability of marine habitat restoration activities. Last year, my company, BC Kelp, partnered with North Island College, the Vancouver Island Sea Salt Company, and the Pacific Urchin Harvesters Association to explore the potential of biochar as a supplemental material for aquaculture and restoration. The study demonstrated the ability of biochar to grow bull kelp, and the results showed that biochar activated with seaweed extract grew kelp at a faster rate than biochar with no nutrients. Concurrently, I have been running a study here at the Vancouver Island Sea Salt Company, where I would regularly harvest marine nutrients from our reverse osmosis machine and circulate them through my own biochar aquarium. I would take microscope observations of the nutrient to see what was going in the tank, and then I started sampling the biochar to see what the biochar was absorbing. And it's clear that the biochar is absorbing marine nutrients from the environment. This is important because the coastal waters of BC are already nutrient rich, in some cases too rich, and you're not allowed to use fertilizer. But by putting biochar in the water, it will absorb the nutrients from the environment, and that will assist the kelp to grow and survive. So it speeds their growth with the expectation that the sporophytes will quickly outgrow their relatively small supplemental biochar and establish or hold fast on the seed floor. The BC Centre for Innovation in Clean Energy call for carbon dioxide removal technology comes at an opportune time when we must decide how to build on the results of our biochar research. And the next obvious step is to take biochar to an aquaculture site to demonstrate biochar in coastal aquaculture and restoration. To do this, I have secured a deep water shellfish site in Vanguard Bay, Nelson Island. My short-term objective is to engage with DFO and amend the terms of the site to include experimental biochar-based aquaculture along with traditional kelp and seaweed production. This site will be linked to a land-based biochar coastal fire smart resilience center where local forest residue from arborists and wildfire risk reduction pruning is collected and processed into biochar. This project has cascading carbon dioxide removal benefits, first from encouraging wildfire risk reduction pruning, to then making biochar from sequesters carbon and takes it out of the carbon cycle. Then the application of biochar specifically to increase the scalability and survivability of seaweed aquaculture and restoration can remove exponential amounts of carbon dioxide from coastal waters and provide tremendous downstream ecological benefits, like fisheries enhancement. The beauty of applying biochar in coastal restoration is the scalability and transferability of this opportunity. All you need is forest residue a biochar kiln, and a location suitable for habitat restoration. Not long ago, 2021 was a devastating year for aquaculture in the Strait of Georgia, as a record heat wave wiped out shellfish and seaweed populations. By demonstrating biochar's potential in restoration in aquaculture, we can kickstart the adoption of biochar and prepare our coastal environment for the next major heat stress event. Every community on the coast, a First Nation, a town, or simply a cottager can champion their own site by making biochar and providing this supplemental material for coastal habitat resilience. The Vancouver Island Sea Salt Company on Shelter Point Farm is an excellent location for the initial Coastal Fire Smart Resilience Center. This location has access to salt water, sea salt byproducts, and excess heat that provide inputs not just for the cultivation of seaweed, but the fermentation process to make seaweed extract as well. Biochar from the kiln can go directly to the aquaculture tanks to filter water and be used as a supplemental material to grow kelp and shellfish to feed the aquaculture site. Kelp will then be harvested from the aquaculture site to be processed in fermentation tanks with distilled water, biochar, calcium, and magnesium to create a superior seaweed extract product. I have been selected to present my abstract at the International Seaweed Symposium in Victoria, May 4th to 9th, and I'll be exhibiting at booth 1 of the Victoria Conference Centre if anyone would like to learn more about my initiative. My goal is to raise enough money to fund an RT biochar kiln capable of producing 1 to 2 tons of biochar per day. CICE funding for this project will be dedicated to operational costs such as biochar processing, seaweed hatchery, and marine services, labor, and materials. Thank you very much.